If you're tired of surface-level history and want the truth behind the front lines, subscribe now. Today, we're breaking open a forgotten piece of the past. Because wars aren't decided only by rifles, tanks or generals. They are decided by whether a factory thousands of miles away can keep up with a battlefield that consumes material faster than planners ever predicted. In the summer of 1943, the United States was winning ground overseas, but quietly losing a race at home. Ammunition consumption was exploding, and the factories meant to supply it were already stretched to their limits. Why America's greatest industrial advantage nearly broke under its own weight. By the middle of 1943, US forces were fighting simultaneously in the Pacific, the Mediterranean, and the skies over Europe. Ammunition was being burned at a rate no previous war had ever demanded. Infantry units in the Solomons reported expending hundreds of thousands of rounds per week. Air crews flying escort missions emptied .50 caliber belts in seconds. Artillery fire plans assumed endless resupply. The problem was simple and, honestly, quite brutal. The supply was not endless. At the Lake City Ordnance Plant in Missouri, which was, one of the largest ammunition factories in the world, production hovered around 1.4 billion rounds per month. Washington needed closer to 2.4 billion just to sustain operations already underway. The gap wasn't theoretical. Commanders were rationing ammunition, not because convoys failed, but because factories could not physically produce fast enough. How a hidden bottleneck threatened the entire war effort. Lake City was not failing because of poor management or weak labour. It was failing because one critical step in the assembly process had barely changed since the First World War. Feeding empty brass casings into alignment tracks was still done by hand, in a rigid linear motion that punished human endurance and magnified every small error. One slip meant a jam. One jam meant recalibration. Every pause bled minutes. Every minute lost meant thousands of rounds that would never exist. This is where the real enemy of wartime production reveals itself. Not sabotage, not enemy bombing. Seconds. Why observation, not authority, drives real wartime innovation. 19-year-old Evelyn Carter was not an engineer. She had no authority and no title. What she had was proximity to the problem. She watched the same repetitive motions hour after hour. Pick, place, slide, a loop disguised as a line. And she noticed something others didn't. The motion itself was circular. The system wasn't failing because workers were slow. It was failing because the process fought human rhythm instead of working with it. Her insight wasn't technical. It was mechanical logic born from fatigue. What if the motion was carried by a rotating system instead of hands? What if feeding casings worked like a Gatling gun in reverse, distributing load through rotation instead of linear repetition? This is an important lesson for anyone studying military history or logistics. Breakthroughs rarely come from abstraction. They come from people who live inside the system long enough to feel where it hurts. How a crude idea became a machine that changed production math. Evelyn's first mock-up failed publicly and, well, messily. Casings scattered, the wheel wobbled, workers laughed. But, failure revealed the real constraints. Weight mattered, speed mattered, stabilization mattered. With help from mechanics and engineers willing to test anything that promised throughput, the design evolved into a steel rotating feeder. Heavy, overbuilt, damped against vibration. Slow enough to control, fast enough to matter. When installed on a live line, the results were immediate. Feed rates jumped from under 500 casings per minute to well over 700. Jams decreased. Workers' hands moved less. Fatigue dropped. The line stopped fighting itself. Within hours, supervisors realized what they were seeing. This wasn't a marginal gain. This was a shift in scale. Why small efficiency gains reshape entire wars? A 10-minute reduction in stoppage time doesn't sound dramatic, but when it's multiplied across 12 lines, 2 shifts and 30 days, it becomes millions of additional rounds. A 5% efficiency gain becomes tens of millions of bullets. That's enough to support entire divisions, enough to sustain offensives that would otherwise stall. This is the side of war that's rarely shown in documentaries. Victory isn't just won at the front, it's manufactured. How this lesson still applies beyond World War II. The takeaway here isn't nostalgia, it's principle. Systems break where repetition meets scale. If you study military logistics, emergency preparedness, or even modern supply chains, the same rules apply. Identify the bottleneck. Don't demand more effort from people already at their limit. Change the motion. Change the flow. Throughput is endurance, not speed. Evelyn Carter didn't invent ammunition. She didn't redesign weapons. She altered a single motion in a single factory. And, that change rippled outward across 2 oceans and multiple fronts. If stories like this matter to you, if you want history that explains how wars are actually sustained, subscribe to Warfare Frontlines and share this episode. The front line begins long before the first shot is fired.